Now we are going to discuss the implementation of first readers writers problem. That means a number of readers are there and a number of writers are also there. Readers means readers want to read a shared variable, whereas writers want to write that variable, or it is modifying the content of that particular variable. If a number of readers are reading, then there is no possibility of any type of discrepancies, because reading by a number of processes is creating any problem. But in between, some writer is writing or modifying the data, there is problem. So in that case, here the implementation of readers writers problem means a number of readers are there, a number of writers are there, and here for a shared variable, if some process or some thread is reading that we want to read that variable, initially it has to acquire that variable and the read count variable. The read count variable means the number of readers which are reading that variable, and that has to be incremented. Once it is acquiring that, it is incrementing that value. That means at any point in time, the read count variable, see here, wire to other computing, p of mutex means it is acquiring that mutex variable. Acquiring that mutex variable means it is checking whether the value of this mutex is 1. If it is 1, then that is free. Then it is decrementing the value of that mutex, then that will be 0. Then other process has to wait. Then the read count is incremented. That means number of readers, that means number of readers 10, means now 10 different processes are reading that particular variable. And now after that, the process which is having this mutex variable, it is checking the value of this read count. That means if it is 1, means only one reader is there. That means this process is the first reader. Now it has to block the block writing. So in that case, it is trying to acquire the write block. But if the read count is 2, then there is no need to acquire that p of write. Why? In that case, the first reader already blocked it. If you are the first reader, then you have to block the writes. But if you are the second reader or third reader, there is no need to acquire that block, because some other readers already blocked it. Okay. So here we have two semaphores. First is mutex and the second one is write block. As you know, a semaphore is binary. Here in this case we are using binary semaphore, and for this binary semaphore there are two states, 0 and 1. That will be initialized to 1. And p of mutex means it is checking, that means some process is taking the value of this mutex, and if it is 1, that is decremented by 1, and it is reset to 0, and it is acquiring that. And then other processes has to wait until this becomes 1. So after completion of the job assigned to that particular process which is gaining that mutex, after completion of that task, when v of mutex is done, then that will be freed. That means the value of v is incremented. Then other variables or other process which are going to acquire this mutex variable or this semaphore, they will get it, and they will do the particular. That means once you have that mutex in your hand, that means p of mutex means it is checking the value of this mutex, and if it is 1, that will be decremented by 1. If that is 0, then this process has to wait until this mutex variable becomes 1. Okay, so once that is 1, then the current process decrement that mutex variable by 1, then after that read count is incremented. When the read count is 1, what will happen? That means you have a shared memory variable and read count is equal to 1 means this process which is having this mutex variable is the first reader. Then you have to block writes to that variable. So again you are going to acquire that p of write block, and once it is done, v of mutex means you have freed the mutex variable. Then some other readers can acquire that, and after that p of mutex, again after doing this critical section, that means p and v, you have acquired that mutex, you have incremented the count variable, then you have released that mutex variable, and after that you are using some critical section code, and after that now you are going to decrement that read count by 1. For that, what you are going to use is, again you are going to acquire that mutex variable, and read count is equal to read count minus 1. If read count is equal to 0, that means you are the last reader. Then you can allow the writers. So in that case, v of write block means that write block variable is incremented. Okay, write block variable is incremented, and v of mutex means. So this is the way you can implement the algorithm. This is implemented using semaphore, and here we have two semaphore variables, mutex and write block, and a read count is for counting the number of readers. There is no write count because only one writer is allowed to acquire that shared variable at the same time. If you have a semaphore variable that can be initialized, or you can create it using sum init, 70 star sum means this is the ID returned by that semaphore variable, and p shared means it is whether it is shared or exclusive, that is determined by this p shared variable and unsigned integer value. Sum init initialize an unnamed semaphore at the address pointed to by m. The value argument specifies the initial value of the semaphore. The p shared argument indicates whether this semaphore is to be shared, and the value variable means that is the initial value of that semaphore, and if p shared is 0, then the semaphore is shared between the threads of a process and should be located at some address that is visible to all threads. If p shared is 0, then the semaphore is shared between processes. Okay. Sum post means after acquiring a semaphore, if you are releasing that is using sum post. That means initial value of semaphore will be, if it is a binary semaphore, initial value will be 1, and when it is 1, that is available, that means that is unlocked and some other process can acquire that. If it is 0, nobody can access that. It can be accessed or it can be possessed only after releasing that by some other process which is acquiring that, which have acquired that semaphore. That is, releasing that variable, that semaphore, is done by sum post. And sum wait means if you want to acquire a semaphore variable, you have to execute this sum wait. That means if you want to acquire that, if you are sum waiting, that means it is waiting for the semaphore to be available. Okay, once it is executed, it is waiting for some other process to unlock that variable. Once that is unlocked using sum post, that is, there is a signal to all the waiting processes that semaphore is unlocked. Okay, so that's all about this. if you go through the details of this, and here this reader writer problem is implemented using semaphore, and I already explained the algorithm. You go through this and you will be able to understand this very well. And here in this case we have 10 readers and 5 writers, I think. In this case 10 readers and 5 producers or writers. So that is all for now as far as this is concerned. Here when you are executing this, gcc minus o exp84 minus lp thread, here this minus lp thread should be there, because here also we are using thread. Okay.